GTP3 doesn't look as though it's programmed to do causation. It's not identifying causes. It's just, as far as I understand, it's brute forcing across big data sets, lots of correlations. Oh, am I wrong? Is there some sort of mechanism there for it to identify causes?
Well, the thing is that correlation and causation are strongly correlated, right? And so it's able to discover something that is often indistinguishable from causation. And what makes this discussion difficult is that not everybody agrees what we mean by causality. But often people take this as a given, especially when they want to criticize a system that they think is inferior or that they don't like. So they assume that the words mean what they want them to mean. But many people just use a simulacrum of causality when they try to refer to it, right? So we need a functional understanding of causality.
Exactly.
And my own functional understanding of causality is that it's an artifact not of the world itself, but of the way that we describe the world in certain contexts. The universe might probably be best understood as some kind of a unified state vector that progresses from state to state according to the laws of physics. Basically, physics is explaining the function or trying to find the function that correlates adjacent universe states. And at the level of this unified model where everything is connected to everything in a way, you don't have causality. And causality only emerges when you separate the world into things. Because we cannot measure the entire universe at once and cannot observe it all at once, there is no hope that we can model the universe as a unified state progression. So yes. So what we do is we take out different parts of the universe and treat them as separate objects. And these separate objects are all described by their own state space and their own transition function that moves them in that state space. And these objects might share interface, which means they share states where one object can influence the states of another. And so the state progression within one object can influence the state evolution in another object. And this is what we would call a causal interaction, right? So for instance, your computer is a thing that is by itself pretty much deterministic and is following its own evolutionary role, its state evolution. And you can press a key, and that might change everything that happens in the computer to a certain degree. It's going to change the evolution of the computer. Unless you press the key very, very hard, it's going to still be a computer. If you press it too hard, it might break. But as long as it doesn't break, as long as it doesn't leave the state space that still lets it be a computer in your own model, it's going to change its evolution in a certain way. And if you manage to change the evolution of the computer by interacting with it, that is a causal interaction. Mm-hmm. So it's in some sense describes the progression of information through objects in such a way that it changes relevant states in the objects. Mm-hmm. And now we could look at GPT-3 and ask ourselves, is it doing that? And I think it does. So you can give it a context in which it's being asked to generalize over interactions between symbols. So for instance, you can ask it to give you the emotional valence of a paragraph. And you give it a handful of examples where you give it different paragraphs of text and tell it what emotion is dominant just in one word. And then you give it new paragraphs and it's going to tell you the dominant emotion. It works pretty well. Right, this is, in some sense, a causal relationship between the text and its output that it has learned to deduce from your previous inputs. It understands that the output is an object. It understands that the paragraph is an object. It understands that there is a relationship between them. It understands that the relationship is... which means it has a functional model that is actually implemented in this. And you can test this by a function that is being instantiated from the context, right? In some sense, GPT-3 is a compiler that takes the context to compile a certain model that is context-dependent to produce the new output. And it does compile this based on invariances that it has learned before. But it doesn't just learn this because it has seen this exact paragraph somewhere in its training data and the matching that it should do to this paragraph. It is able to discover this relationship between the paragraph and some kind of emotion. And so I did test this, for instance, by giving it as an example.
But I mean, when you say it's not really understanding that the concepts are emotions or that they represent, they're not like Do they
No,
understand the reference in a sense?
it doesn't understand the concept of emotion in the sense as we do it. So it is not able to experience an emotion. But it's if you can ask it, if there was an agent that had this kind of emotion, what would this agent likely do under these and these circumstances? Then it's going to create you a story that is quite plausible. And if you could use the context to describe the situation that you are in, or that itself is in, or a robot is in that is controlled by the output of GPT-3, then GPT-3 would be able to produce plausible behavior for that robot. Right, so it's a very interesting thing. What's the difference between making a decision and predicting what decision an agent would make if that agent is in your situation? Right? What does it mean to be in your situation?
It what an understanding agent would
yes,
make.
Right. So it can make something that is basically a deep fake of
Exactly.
Agentic behavior.